Flack math! Give me some math and I'll give you some flack. Flack math!
So we're going to do lessons 47 and 48. We'll start with 47 since that comes before 48. We're going to talk about powers of 10. Literally and mathematically. Okay? Powers, what's a power of 10? What does that mean? Grace?
It's like, with like the exponents.
Uh-huh.
And like if it's like 10 and then 2,
Yeah.
it means like it's 100.
Yeah, so it's the answer to an exponential problem. Good job. I just realized I didn't take attendance and I feel kind of bad about that. So 1 second here. Don't you worry. Everything's under control. Moving in. Is everybody here?
Everybody except Avery.
Addie, Grace, Madeline, Abby, Kiara, Dylan, Hunter. Dylan, there's Dylan. You're so quiet.
I'm never quiet.
Elijah, Grady, and Maren, awesome. Okay. So let's do it. So now that's mathematically. Now the powers of 10, like 10 has some superhero powers because 10 is so easy to work with. Because how do you multiply by 10? What do you do?
Add a 0.
You add a 0 if it's a whole number. What if it's a decimal number? Just move the decimal. And a power of 10 is like 100 and 1,000 and 10,000. When you multiply or divide by powers of 10, you just move the decimal. That's it. So 10 is nice and powerful because it's so easy to work with. That's the whole metric system, remember? Converting the metric system, you don't do math. You just move a dot, okay? Yes, Kiara?
Also, it's easy to find multiples and factors.
Yep.
Because it's an even.
Yeah, even number that ends in 0, that's easy. Yeah, so let's get going here. So we said 10 squared is just 10 times 10, which is just 100. Does anyone know the shortcut to figuring this out?
Oh.
What's the shortcut?
Addie? You add as many zeros as there is.
Yeah, that's right. That's what she was going to say. You got to be quick. You got to be quick. It's all right. So 10 to the 7th is 10. What is that? 10 million? It's a pretty good number. Okay, so you're just adding that many zeros. But here's the deal. You don't really need to know that because you can stay in the world of powers of 10. So when you multiply by this number, you're moving the decimal this many places. Blimp, blimp, blimp. So remember, when just a 10, you just move it one place to the right. If you multiply by 100, you move it 2 places to the right. This tells you how many places to move the decimal. That's kind of nice. So if I said something like this, 7 times 10 to the 6, well, that's going to be 7. And then I'm going to move the decimal 6 places to the right. So what's the answer? $7 million, okay? And you could look at it like this. This actually means million. This could be a way to spell million. 10 to the 6th equals million. So 7 million. And look at this. This is like 10, but I mean, if I multiply by 10 to the 7th, it could be like 6 times 10 to the 7th. It'd be 610 million. 610 million. Remember, 610, 6T, 6T million. Okay? So let's do some other things. Let's try this. What if I wanted to do this? What if I wanted to multiply 10 to the 3rd times 10 to the 3rd? What's that going to equal?
10 to the 9th.
Good guess, because that was a guess. but not correct. Lots of hesitation. That's okay. You're being careful. Do you have an answer, Kiara? What?
1 million.
It is 1 million. Okay, now look at this. This is just 3 zeros, right? Times another 3 zeros. What do you do with the zeros when you multiply? Just squish them all together, right? So you get 6 zeros, which kind of makes sense. If you're doing this, you have to move it three more places to the right, blip, blip, blip. So what happens? You add the exponents. What? How are we adding when this is a multiplication problem? Well, you're not really adding. This isn't an addition problem. This is still a multiplication problem. But you're counting how many total times you're multiplying by 10. So that's 10 times 10 times 10 times 10 times 10 times 10. How many 10s are you multiplying?
6.
6. So 10 to the 6. So it makes sense that you're adding those exponents. Remember, adding is just glorified counting. 5 plus 3, you're just counting from 5. You're counting 3 more than 5. So, and then multiplication is just glorified adding. Exponents are just glorified multiplication. Okay? So, it's kind of weird to remember to add, but the first reaction is to multiply because you see that multiplication problem. So that's why most people, like Grace, said 10 to the 9th because she multiplied 3 times 3. Okay, what about this? What's 10 to the 5th?
The board's so dirty that the
I know.
one's in with it.
What's 10 to the 5th times 10 to the 2nd? Quick! Shout it out.
10 to the 7th.
10 to the 7th, right? You just add the exponents. That's 10, 5, or 5 tens being multiplied, and then another couple of tens. So that's 10 to the 7th. All right. So let's use our logic, okay? So turn your math off for a second and see what you would do in this case. So if this was 10 to the 5th times 10 to the 2nd would be 10 to the 7th. What is 10 to the 5th divided by 10 to the 2nd? What do you think you're going to do with those exponents? What's your gut tell you? 10 to the 3rd. How'd you get that?
I don't know.
5 minus 2.
Yeah, you subtract. So it makes sense that if you're multiplying powers of 10, you add the exponents. But if you do the opposite of multiplication and divide by powers of 10, you do the opposite of adding the exponents, which is subtracting the exponents. Well, let's see. If I did this, this would be 10 times 10 times 10 times 10 times 10 divided by 10 times 10, right? Well, when you divide, you can just reduce this fraction. Look what's happening. I'm going to cancel those two, and what are you left with? 10 to the 3rd. Okay? So 10 to the 3rd. This is 5 minus 2 equals the 3rd. Okay? So this is kind of hard to remember, but you can just, if you forget this rule, these are just shortcuts. So you can actually do this math if you wanted to. 10 times 10 times 10 times 10 times 10 times 10 times 10. If you do that, then you're going to get 10, you're going to get 10 million or 10 to the 7th. Okay? Yeah, question, Hunter? Or you just, okay. You itched your chin with like this, and I thought
Yes.
okay.
My thinking was.
All right, so here's the first test. I'm going to erase with this. Let's see if it makes it whiter. Oh my goodness.
Oh, that is insane.
You just need to clean those.
So it's a little whiter over on that side, I guess.
That's still pretty dirty, but it looks so clean.
I know. It's terribly dirty, but relatively, it's so clean.
Compared to before.
Yep. This is good exercise. You know how many calories I burn every day for teaching? Guess. Just standing up here and teaching. How many calories do I burn, Hunter?
5,000.
Oh, I wish. Not quite that many.
Uh,
It depends. Like my 8th grade class, I have to talk louder, so my abs are like. So it's harder with 8th graders. You have to talk louder.
Why?
Oh, have you met our 8th graders? So,
hearing problems.
so yeah, I burn 100 calories an hour ish. So it's not a whole lot, but I could be sitting at home watching Netflix and not burning any calories.
You'd be eating them.
That's right. Like Takis or something. Those are a trap. Okay? You can't just have one. You know, you have to have like 70. And then your mouth goes numb. Anyway, now I want Takis. Whatever. Okay, so do you guys remember when we did this? When we did 5,206 and we wrote it in place value notation and exponential notation. This is 5 times 1,000. Remember doing this?
Yeah.
Plus 2 times 100 plus 6 times 1 because there's no tens, right? You remember doing that?
Yep.
Okay, this was called expanded notation. This is expanded notation. Now we're going to write it in exponential notation.
Wait, is this still lesson 47?
Yep. So exponential notation is just the same thing, except we're writing it as a power of 10, not the answer there. So 5 times, what is this? 10 to the what exponent? Yes, Hunter?
10 to the third.
10 to the third. It's basically how many zeros there are, right? So 5 times 10 to the third plus, how do you write that? 10 to the second. Okay, how do you write this?
10 to the first.
Not first. How many zeros are there?
0.
0. So that's how you write that in exponential notation. Weird, huh?
Yeah.
So 0 or 1 is a power of 10. And this is weird. We're going to talk about this more in algebra. But when you raise anything to the 0 power, the answer is always 1. So 5,368 to the 0 power equals 1. Is that weird? I think it's weird. I think a lot of things are weird, but doesn't make them not true. Okay, so this is exponential notation. You might be asked to do that. So let's go back. This is what your homework is mostly going to look like. You're just multiplying by powers of 10. So 10 to the squared is actually 100. Well, you already know how to multiply a decimal number by 100, right?
Mm-hmm.
But now it's even easier because it tells you how many places to move the decimal. How many places do you move the decimal? 2. In which direction, right or left?
Right.
Right. So you're going to move right 2. So the multiplication says go right. And the 2 says go 2 places. So what if this was a division symbol? Which direction would you go? Left. You would just move it left that many places. Okay, so what's my answer?
4,623 and 5 tenths.
Good. Nice job saying it correctly. Oh my gosh, I just saw this on the computer screen and it looks just as bad as it does in real life. Okay, good. All right, let's try something else. Let's try this. 3.14 times 10 to the 4th. Somebody besides Grady or Grace. You guys have been doing great answering a lot of questions. I just want to give other people a chance.
Addie raises her hand. She's raising it
Internally, internal hand raise. All right. Anybody else? Some of our boys. See, Grady knows. You're going to let Grady show you up. Dylan,
Yeah, Dylan.
what do you do? This is nice because it's not really doing math. It doesn't feel like you're doing math. What do you do? Hunter?
I have an answer.
Okay,
31,400.
31,400. Oh, that got big. Let's see if you're right. How many places do we move this? 4 to the right, right? 1, 2. Uh-oh. We're out of digits, so what do? We need to add 2 more zeros. So I'm just going to rewrite these digits with 2 zeros after. Then I'm going to figure out my comma. It goes right there. 31,400. Good job. Does that make sense? Is that doable?
Are
Can
most
you guys
of our
do that?
problems gonna be like this?
Yeah. Sorry if it's too easy. Didn't mean
that's
to.
good. You don't need
I
to be sorry
offended
for
you.
too easy.
Okay, so when I say something like our national debt is $5.3 trillion. I don't know what it is. But how do you say 5.3 trillion? Well, that's 5.3 trillion. Well, how do you say trillion? Well, trillion is, let's see, that is 12 zeros. Trillion is 12 zeros. So this is times 10 to the 12th. So if you go 5.3 times 10 to the 12th, that's 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 5.3 trillion. Or in other words, 5,300,000,000,000,000,000. Whew. Yes, Kiara? Yep. Okay. That's it for lesson 47. You guys feel okay with lesson 47? Oh, that's not it for lesson 47. There's more, but it's stuff we've already talked about. Here's just another one, example 5. Let's just move on to example 5. Here's 3.5 divided by 10 to the 4th. Let's see if you guys can do 3.5 divided by 10 to the 4th. Who's got this one? Are you scratching your head or you're raising your hand?
Yeah, he was raising his hand.
Okay, I'm just gonna ask you yes or no questions. Okay, ready? That was the first one. Are you ready?
No.
Okay, which way do I move the decimal? Left or right? Do I move it left? Or do I move it right? I lied, it's not a yes or no question. Which way do I move it, left or right? Left.
No, it's up.
And how many places do I move it?
Down.
Once.
Okay, if you move it once, that's like dividing by 10. But this isn't dividing by 10, it's dividing by 10 to the 4th. So the cool thing about these problems is your answer is on the board. How many places do I move it to the left? What other number do you see there? 4. So I'm going to move it left 4 places. So left division means move it left. The exponent means how many places you move it, either left or right. So you're going to move this one 4 to the right because it's multiplied by 10 to the 4th. This is 4 to the left. Okay, well, the problem is we ran out of digits really quick. So what is my answer? Hunter?
0.0000035.
Oh, we got 2 out of control with the zeros.
I added 1 extra 0.
Okay, so it's just 0.0. So if it helps, you can add the zeros in right there. That's fine. And then that's where you end up. So it's always 1 less than you think. You think, oh, wait a minute. Wasn't it 10 to the 4th? Shouldn't there be 4 zeros there? No, because it started after that first non-zero digit. So there's your answer. All right, do I need to do more with this?
Nope.
You guys feel okay?
Nope.
How about exponential notation? Do you guys feel like you can do this?
Yep.
Okay, good. All right, moving on to 48. Just keeps getting cleaner and cleaner.
You need to get like a Fitbit. It act like you're
I know. I'm all right. Although wearing a mask, I think I burn more calories wearing a mask because I have to breathe harder.
Why do you have to wear a mask when you're teaching? Because you're like 12 feet away from everyone.
No, it's actually the rule is if you're presenting or you're a speaker, then you have to be 25 feet away. Because my secretions go farther. So apparently, theoretically, I could spit on Elijah from here.
Please do.
Yes, please do.
Okay.
No, do it to Dylan.
All right, lesson 48.
Yeah, I agree.
Lesson 48, we are going to talk about, we've done this a little bit before, but we're going to talk about fractions, decimals, and percents all together, okay? Because no matter how you talk about a part of something, you can either use fractions, decimals, or percents, okay? Now, percents look pretty and they're nice to talk about, but mathematically, you can't really use percents. So you have to change percents to decimals or fractions before you can use them in a calculation. So, but they're fun to talk about. But let's see if we can give the fraction, decimal, and percent of this shaded area. Most of you guys should know this, right? So what's the fraction? What fraction is shaded? 1/2. Okay. And then decimal. 0.5. Right. These are things that you know. And what's the percent?
50.
Okay. So if you look at this, and here's a good reference one. Let's say this was a 51%. Well, that's 0.51 and then 51 hundredths because 51% is 51%, right? Because a cent is a hundredth. Yes.
It's probably closer to either 49.
Yeah, I know. It's not drawn perfectly. So, okay, so it kind of makes sense. Like going from decimal to percent to decimal. That's what we just did in the last lesson. We just moved the decimal, right? So you're just dividing by 100 or multiplying by 100. So it's always two places. No more, no less. Okay, this is not 5%. This is 50%. Okay. Now going from a percent to a fraction isn't terrible, but the hard part about going from a percent to a fraction is the reducing part. Over here, you can't reduce 51 over 100, but you can reduce 50 over 100. Well, you know how to reduce that though, or you can just look at the diagram and tell that it's 1/2. But make sure after you convert a percent to a fraction that it's reduced. If it's not, then reduce it. Okay. All right. So let's try some examples. So let's try 7/10. I'm going to write this as a decimal and a percent. Okay. Well, first of all, just say it out loud. How do you write 7/10 as a decimal? Grady?
0.7.
0.7, right? Place value, 7 in the tenths place, 7/10, right? Okay, anyone know another way to figure out how to change a fraction to a decimal? We've talked about this. How do you change any fraction? This will work with any fraction, not just one that has a 10 as a denominator. That makes it easy, right? Because tenths are decimals. But what if it was like 3/7? How do you change a fraction to a decimal? How do you figure out what decimal 3/7 is? Nobody knows? Well, this is good. Now I get to teach you something. It's awesome. Well, this is just a division problem. Look at this. Let's test it on something that we know. 7 over 10, that's another way to write a division problem. Did you know that this is the only way, 1,000 years ago, this is the only way mathematicians wrote division problems, is like that, okay? Now this whole thing, 7 divided by 10, this came later. Do you know what this actually means? This is actually, if I drew a rectangle, These are like the sides of a rectangle. How do you find the area of a rectangle? Length times width, right? Okay, so that's where that came from. But how many times does 10 go into 7? Good answer. Nothing. 0. Okay, so then add a decimal and a 0. Now how many times does 10 go into 70?
7.
7. And then you're done, right? Done. Okay, what's another fraction that you know the decimal of? Give me a fraction that you know the decimal of. Grady?
9/10.
9/10. So that's another tenth, so that'd be 0.9. So give me something that's not a tenth. Like another fraction that you know the decimal.
7/8.
Do you know the decimal for that?
No.
So let's do one that you know of. Like what's 3/4? Point.
0.75.
0.75. Let's see if this works with 3/4. 3/4 is 3 divided by 4. How many times does 4 go into 3? 0. Well, we knew that. How many times does 4 go into 30?
7 times.
7 times. 7 times 4 is 28. Subtract. Bring down another 0. How many times does 4 go into 20? 5 times. Look at that. It works. Every time it works. Okay? So, to change a fraction to a decimal, all you have to do is that math. Remember, a fraction is just a division problem. So just do it. And then that'll give you your decimal. Okay? Now, this is the easy part. How do you change a decimal to a percent? Maren? Yeah, that's her answer. Yep, move it over 2 places. So is it 7%? Nope, 70%. 2 places. Don't stop there. Always 2, no more, no less. Either 2 to the right if you're going from decimal to a percent, or 2 to the left if you're going from percent to decimal. Okay? All right, let's try another one. Let's see here. Let's try 2/3. 2/3. Does anyone know what that is, just offhand, what the decimal is, or what the percent is, 2/3? Does anyone have that memorized?
I know.
What is it?
33.33.
Okay, that would be 1/3.
Oh, 2/3.
What do you got, Kiara?
66.
66 and 0.6 repeating, or 66 and 2/3 is what that is. That's right. Okay, so percent, right? So let's see here. 2/3. What? How do you? If you don't know that, how do you figure out what that decimal is? Hunter?
Multiply. Or not multiply, divide.
Divide what by what? 2 by 3. So how many times 3 go into 2? Well, we already know that's 0. But how many times does 3 go into 20? 6. You get 18. Bring down another 3 goes into 20. Uh-oh. 6, 6, 6, 6, 6, 6. So this is just, how do I write that? 0.
6. No.
Adeline?
With the line over it.
Yes. Repeating decimal, right?
Wait, but I thought it was 6, 6, and then the line over both of them.
No, because it's the 6 that repeats.
Not the 6
So
and 6.
yeah, there's a if you'd said 0.66 repeating, then this would not be a part of it. Well, that's bad anyway, right? So then it's just you have to repeat 2 6s at a time. No, you're just repeating 1 6 at a time. So 0.66 repeating with the line over it it's not grammatically correct, but technically it's the right answer. Okay? Now, how do you write that as a percent? That's weird. How do you move the decimal over? I don't see any numbers. Grady?
You still move it over by 2 decimals and then it'd just be 60%.
Well, if you move it over, remember there's a bunch of 6s there.
Gotcha.
So now we're here. So you kind of have to do that, right? Because there's just an infinite number of 6s to the right of that decimal. So when you move the decimal over, if you run out of digits, you never run out of digits. There's a bunch of 6s over there. So you need to make sure that that 6 is there. And that 6 repeating can go there if you want, or you can say 66 2/3. It's actually better to write percents with fractions than it is with decimals. Okay? But 66.6 repeating percent, I'm good with that. Okay? Do you see why it's that and not 60%? Okay, that's a common mistake. Don't make that mistake on your test. All right, let's do another one here. This is what a lot of your homework will look like. You'll have like an empty chart here. Look at how great the lines are. So then you'll have fractions, decimal, then percents. Okay, so this is what your homework will look like. And then it might start with this, 51 over 100. And these are what they call the reference numbers. So this is just a good, kind of like here's a little template or an easy way to remember. Okay, I see what they did there. They just threw that over 100. They just moved the decimal over there. Okay, so starting with these reference numbers is nice to have so as a reference for when you do your math. Okay, and then this is what they're going to do. They're going to give you like they're going to give you different things like 0.8 over here, and they're going to give you 1/3, 1.5, then 60%, and then you have to figure out the rest. Okay, so on your test or in your homework, it might be like, here's A, figure out A, B, C, D, E, F, G, and H. So you have to number those and figure those out. Okay, this problem looks like a big problem, but you could probably get most of this done in 30 seconds. Okay, what looks like the easiest thing to do first?
A.
Yeah, what's A? If this is 0.8, how do you say that as a fraction? 8/10. Are you done?
No.
No, why not?
4/5.
You have to reduce it, 4/5. Good job. If you don't, this is going to be minus 1/2. So I'm going to take half points off of that. So don't forget to reduce. Whenever you have a fraction as an answer and you can reduce it, and it's not, I'm going to take half off because I'm a jerk. That's right. No, I just want you to give me correct, grammatically correct answers. 8/10 is not wrong, but it's just not grammatically correct. I'm not going to say 8/10. All right. I ate 2 halves of my lunch. That's right. I ate the whole thing. Okay. How do you change that to a percent? Marin, what's your little?
Oh, 2 over to the left.
Yeah, 2 over to the right. If you're going from decimal to a percent, you move it 2 to the right.
It's definitely, I believe it's 8,000 if you move it to the left.
Yeah.
If you
So don't move it to the left. Okay. All right. What about this? Can you do that in your head? What's 1/3? Is a decimal. Do you know that? Do you have that one memorized? 0.33333. How do you write that? There you go. Okay. Now what's that as a percent?
33.
0.3 repeating, or 33 1/3%. Okay, good job. All right, what about this? This is weird. 1.5.
Wait, are you supposed to write the decimal as a fraction?
It's better to write it like 33 1/3%.
Can I
But
correct you on that?
no, but I said that you could do that.
Okay.
Yep. What's 1.5?
I think it's 1.5.
Yep, 1.5, right? Or this is 1 5/10. If I just said this number out loud correctly, 1 and, remember the decimal is and, 5/10. Reduce 5/10 to 1/2. 1 1/2. There's your answer. Good. Now, what about as a percent? Hunter?
150%.
150%. So remember, 2 places. A lot of you will be tempted to stop there because you're like, well, it's already 2 digits, right? Because it's 1 and 5. No, you have to move the decimal 2 places always. No more, no less, no exceptions. 2 to the right, you have to add a 0. So 150%. Okay? That makes sense. It's over 100%. 1.5 of something is all of it plus another half. So 150% is all of it and plus one more. Have you ever heard that from your coach or anything? I want you to give me 150% out there on the court.
No, I didn't hear 110. Never heard 150.
110%. If they say 110%, I think when I was a kid, I remember doing this to my coach. That is mathematically impossible.
And
I'm
your
able to
coach
give
would be
you
like, you're
100%.
benched for the game.
That's right. You're a quitter.
I want you to
What
get 173.7%.
So that's when I started to think less of my coaches. If they needed a better education, right? Can't give you 110%. All right, so 150%. All right, 60%. Now this, how do you write that as a decimal and a fraction? Somebody else who hasn't answered yet. Adeline, you haven't answered a lot.
For decimal, you move the decimal over 2 places to the
Uh-huh.
left.
So what is it?
6.6.
0.6. Good job. All right. Somebody else. Elijah, it's up to you. How do you write that as a fraction? So if you say 60%, 60%, that's 60 per, and what's a cent? What's a cent? How many cents are in a dollar? 100, so 60%. Do you see that? Now reduce that. How do you reduce 60 over 100? What do you get? Do you not know, or are you being shy? Or both?
I feel pressure from this one.
I know. It's just, I know. It's so
Yeah, Dylan's
pressure.
like,
Okay, well, I can divide by 10. I get 6/10. So, but 6 and 10 are both even. So then you get 3/5. Okay, so that's the gist of what you're going to be doing in your homework. Can you guys handle that? Okay. Any questions? Feel all right? Okay, good job.
Black math, give me some math and I'll give you some flack. Black math.